Hello everyone, welcome to this course Process Dynamics and Control. I hope all of you are doing well. So my name is Dr. Purushottam Dasari. I am an assistant professor in chemical engineering and my specialization is process control. So I completed my PhD in process control and my academic and research work mainly focusing on understanding the modeling and controlling dynamic chemical process. So I have been teaching courses related to process dynamics, control systems and modeling, and I have worked on both theoretical concept and practical industrial problems. So over the years, I noticed that students find this subject a little bit difficult. So not because of subject is hard, but because of the physical meaning is not understanding clearly. So the main motivation behind this course is simplify this process control concept. So in this lecture series, I will not directly jump into equations. First, we will build the intuition, and then we will connect that intuition to mathematical models and controllers and applications. Okay, so this course is useful mainly for undergrad people and then postgrad people and chemical engineering students and then GATE aspirants, and if anyone who wants a strong foundation of process control. So my teaching approach will be the simple explanation, and then step-by-step derivation will be there, and then real process example with applications, and continuous connection between theory and practice. So if you follow this course sequentially, you will be able to understand the smooth transition to this course content. And with a brief introduction, let us begin this course. So in the first part, I will explain the course structure and reference books, and then we will move into the fundamental concept of process dynamics and control. So before we begin this actual subject, let us briefly explain how this course will taught and which textbooks we will follow. Okay, in subject like process dynamics and control, selecting a right book is very important because it shapes the way you understand its concepts. Okay, the main reference book for this course is written by Donald R. Kuffner, titled Process Systems Analysis and Control. Either you can go for the second edition, third edition. So this is a book widely followed across university in India mainly and abroad. So it starts from the fundamental, explains ideas in a clear and logic manner, and uses examples that are closely related to the real chemical engineering process. So I have chosen this book because it helps you to understand not only how to solve the problems, but also why process control is essential in real industrial plants. So in my lectures, I will use this book only as a reference and explain the all topics my own words with a strong emphasis on intuition, the physical understanding and practical applications. So if you attend this lecture regularly and focus understanding these ideas, you will find semester examination and then gate questions and advanced control subject much easier and more confident to handle. We will also refer to this book, Process Dynamics and Control by Seberg. And this book will be used only to understand the concept more clearly whenever we required deep analysis. Okay. We will also refer to book Chemical Process Control by George Stephanopoulos. So this book will be used only for understanding the overall process control philosophy and industrial viewpoint when we need it. Okay. We will also refer to the book Process Control, Modeling, Design and Simulation by Van Beckett. So this book will be used mainly to understand the modeling and simulation aspect of process control. So now let us understand what we mean by controlling a process. When we say that we are controlling a process systems, it simply means that we are trying to influence the way the process operates. So this influence can be form of guiding the process or regulating it, so that the process gives us a desired outcome. Okay, in other words, control means making the process behave the way we want. Okay, so in fact, you may have already seen many examples, control and laboratory experiments. Okay, so for example, if you take a heating water bath, a control unit is used to maintain the temperature at a desired value, how much we want to maintain the temperature. Even if the surrounding changes, the controller need to adjust the heating so that the temperature remains constant. Similarly, the pressure regulator. It is used to supply air at constant pressure. Okay, remain steady. That's what we want. So these are simple examples so that control is already a part of many process operations. Okay, so in all examples we discussed earlier, you may notice that control unit is always present. The main role of this control unit is to ensure that process operates. The process operates in a steady state and maybe desired manner. So what exactly we want. Okay. However, it is important to understand one key point. All industry process are dynamic in nature. That means the process variable do not remain constant automatically. Okay. In simple words, we'll just go through here. So the behavior of the process change with the time. Okay. When we change in the input, the output does not respond instantly. Okay, so it responds gradually. Even the disturbance, such as change in the feed, temperature, or environmental cause, the process maybe it vary with the time. Okay, so because of this dynamic nature, because of dynamic behavior, we cannot rely on process to remain steady by itself. Okay, so that is why the control is required. Okay, to continuously adjust the process and keep it close to our desired operating condition. How means our set point. Okay, so let us see the role of control engineering. A control engineer has two main responsibilities. Okay, first the control engineer must understand how process behave with time, then how variables like temperature, pressure, and level change when there is a change in the input or when disturbance occur. So next one is based on the understanding, the control engineer designs suitable methods to control the process and make it behave in the required manner. So like simply speaking, a control engineer must first understand the process and then control the process. Okay, so these are the main important thing as a control engineer. Control engineering is important for every chemical engineers. Okay, design engineers must think about how equipment behaves at the time, because real plants do not work at steady state all the time. So the plant engineers must handle disturbances and keep the plant running smoothly. Engineering doing experiments must control their equipment properly to get correct the final results. So the final summary we can say like control engineering is needed to design and then operation and experiments. So now let us understand why process control is important. In fact, without process control, it is not possible to operate most modern chemical plants. So process control is required to run plants mainly for safely, and it helps the plant operate reliably. So without frequent problems, it also helps the plant operate profitably. Finally, process control ensures that industrial quality standards are satisfied. So, so the process control is essential for safety and reliability and profit and finally quality. So next we'll discuss about control in process industries. So over the years, both theory and application of process control have changed because of the technological developments. Okay, with the growth of the computers and communication technologies, the role of process control is continuously changing. So today we can clearly see two roles of process control. The first one is the traditional role, where the control is mainly used for safety and stable operation. And the second is the expanded role, where the control is also used for automation, optimization, and better plant management. So you can simply we can say the process control has evolved from basic control to advanced computer-based control. And now we will discuss the traditional role of process control. So in industrial operations, process control plays an important role. Okay, it helps to maintain safety and environmental impact and improving the process performance. So this is done by keeping important process variable close to our desired values. So for example, consider a chemical reactor with highly exothermic reaction. Okay, so if the reaction is not properly controlled, temperature can increase rapidly. So many variables can change, and this may lead to liquid overflow or high temperature, which is called runaway. Okay, so process control is used to prevent such dangerous situations. Okay, so traditional process control mainly focus on safe and stable operation of the plant. So now let's see the traditional role of process control with example. So in this example, so a control system used to maintain a important variables at their desired values. So first one is the liquid level. The liquid level inside the reactor is maintained near the desired value by adjusting the outlet flow rate. Okay, this is done using the your level controller. Next, the reactor temperature. The reactor temperature is maintained near the desired value by adjusting the coolant flow rate. So this is what done using the your temperature controller. By controlling this level and temperature, the reactor operates safely and smoothly. So good temperature controller also reduces the formation of unwanted byproducts. So this is what helps to reduce the waste and minimize the environmental pollution. So this is what the traditional process control keeps the plant safe, stable, and clean. So now let us understand expanded role of process control. A modern industrial plant is made up of many unit operations working together to produce your final product. So an important part of such plant is a control room, where the operators continuously monitor the plant operation. Today, computer-based control systems collect data from different units and automatically adjust the process variables. So this is what helps in maintaining the smooth and stable operations. Okay, the main system here, the main system used for purpose is called distributed control system or DCS. So the DCS communicates with the field instrument such as sensors and control valves through communicate the networks. So that's called the modern process control uses computers and networks to control the entire this plant. So this is what called expanded role of process control. So now let us see what is DCS. That means distributed control systems. So this is what allows plant operators to do. Okay. First, the DCS helps to operate to see important process variables such as temperature, pressure, level, flow in the control room. The second is continuously check the for alarms to warn the operator if any variables goes behind the safe limits. The third one is the DCS allows to operator to take action whenever required. Okay, so this is the action. This is the action may include adjusting a unit or shutting down the plant during an emergency. So this is what the DCS helps operators monitor, control, and protect the plant. So this slide shows an example of control network of a modern industrial plant. So here if you see the control room is the place where plant operators monitor and control the entire process. Okay, computer is the control room. It displays the important information such as temperature, pressure, level, or flow. So here the DCS interface shows the process units and control loops in a graphical form. So using this interface, operators can easily understand the plant condition and take necessary control actions. So here, the both together, the control room and DCS together form the control center of a chemical plant. So because of advances in computers, so the role of process control has expanded significantly. So today computer-based systems can collect process data and process this information to the real time. Okay, so these systems used not only for process control but also for online optimization. Okay, in addition, computers are used for tasks such as scheduling and production planning. Okay, so modern process control covers much more than basic control of single unit. So today's computer play a major role in control, optimization, and plant management. So let us understand the control using the simple life example. So a bicycle is unstable system. If no action is taken, it will fall. Okay, when ride a bicycle, we continuously adjust our balance and steering. So disturbance such as traffic or uneven roads can disturb this type of balance. So by continuously correcting our motion, we are actually stabilizing the bicycle. So this is similar how our control system works in process. So control means taking continuous action to stabilize an unstable system. So let us now summarize what we have learned in the introduction to process dynamics and control. So process control help us to regulate the behavior of process systems and make them operate at desired manner. So then good control is very important because it improves safety, ensures smooth operation, and increase plant profitability. And we also learn the role of process control has expanded from basic control to advanced, then computer-based and information-driven controller. So the main objective of this process control are to maintain stability and achieve good performance and optimize plant operation. So with the clear understanding of process dynamics, engineers can design effective control systems that are meet industrial requirements. So So the complete this understanding from the foundation for all advanced topics in process dynamics and control. Yeah, thank you for watching. We will continue with the next topic in the next lecture. Thank you.